So this is an important handout to do before you start section 4.4 because section 4.4 has some stuff from section P1 and P2 that you might have forgotten. The first problem on this, the first few problems are just stuff from 4.3 that we did, and the first problem, part A, B, and C, is either you know what the radical reduces to in your head, or you can use a calculator. I don't expect you to do any algebra. So for problem 1A, to do the square root of 81 without my calculator, I would do 9. I wrote 9 because I knew what it equals to. For B, it might be nice if you did the orders of operations, even if you needed your calculator to do the radical. And the orders of operations are radicals first, and then the multiplication second for this problem. And then my calculator, shift and the x with the little square key to give me a template to do the fourth root of 16. The fourth root of 16, I knew it to be 2, but I'm just doing it on my calculator just in case you didn't know. And then 3 times the fourth root of 16 is 3 times 2. The answer to this is going to be 6. And then C wants the cube root of 343, so shift and square root for cube root, or whichever buttons you need to press on your calculator. And this tells me that it's 7. So those I don't really expect to see anything but the answers. Maybe in part B, to show that extra step would be nice. For part 2, this is going to be a big deal in section 4.4, doing radicals with letters. So to do the square root of a fraction, you need to separately do the square root of the numerator and the square root of the denominator. The denominator I could do on my calculator if I don't know what the square root of 49 is. And the numerator, because it's a letter, to do the simplification to get rid of the radical sign, I divide the exponent by the index. And remember, in a square root problem, there's an implied index of 2. So to simplify the numerator, to get rid of the radical, I take the exponent of 8, divide it by the implied index of 2. And for an answer, I'm going to get y to the 4th in the numerator and the square root of 49, which is 7 in the denominator. For part B, I need to do the cube root of 125. That I can do on my calculator if I don't know what it equals to. And for each of the letters, I'm going to divide its exponent by the index. So the x and the y's exponents are going to be divided by 3. If I don't know the cube root of 125, I'll just press buttons to get it. And the coefficient part of my answer is 5. The x is going to have an exponent of 1, which I don't need to write. A naked x without an exponent written has an implied exponent of 1. And then the y is going to have an exponent of 4. 3 wants me to make a table and sketch a graph. So I'm going to do part A first. And very specifically, I'm going to make a table. After I get the table done, I'm going to sketch a graph. And then I'm going to state what the domain and the range is. And I'm going to get that part out of the way first because for our graphs, all cube roots have a domain and a range of negative to positive infinity. So since this is a cube root, the domain and range part, I don't really even need to have the graph in front of me. I know ahead of time it's going to be negative to positive infinity. In terms of the table part, to figure out, because I'm not given a table to start with, the number that I'm going to throw in the middle of my x column, I'm going to get by taking the radicand, the x plus 2, I'll set it equal to 0, I'll isolate the x, and in the middle of my x column for my making a table, I'm going to put the number negative 2. Bigger than negative 2 is negative 1 and 0. Smaller than negative 2 is negative 3 and negative 4. Those are going to be the values I do in my x column. Generally, when I make a graph I do of a cube root, I use 5 points. And I label the axis, normally x and y, but the y-axis I could call f of x. And I need to get my x's all the way out to -4. Usually my y's are pretty small on cube root graphs. So I wrote the numbers 0 through -4 on my x-axis. I don't need more than that. And on my y-axis, I've graphed enough cube roots that I'm pretty sure that going between -2 and 2 it will be fine. Now for each x, I need to get a y. For the first x of -4, I'm going to do the cube root of -4 plus 2. I'm going to round that to 2 decimals. So shift cube root -4 plus 2. I'm going to write that as -1.26. And in terms of plotting, I'd go to -4 on the x-axis and down a little bit more than 1 1/4, but not quite 1 1/2. I don't know, maybe about there. I'm just going to make a dot for that. My next point, I'm going to plug in -3 for the x and get the cube root of -3 plus 2. Back out here, delete the -4, make it a -3. My next y is going to be -1. The next point I'm going to plot is -3, -1. And then I'll do f of -2, which is going to be the cube root of -2 plus 2. And that gives me a y of 0. So my third point is the point -2, 0. I'm just making dots rather than writing the label of the point, but you can write the label if you want to see it. My fourth point, I'm going to do the cube root of -1 plus 2. And that'll give me 1 for its y. So my fourth point is the point -1, 1. And then lastly, f of 0 is going to be the cube root of 0 plus 2. Delete, delete, cube root of 0 plus 2, and I get 1.26. I'll guesstimate that. And then cube roots kind of usually have this S. I don't know if it's really an S, but they kind of have a little bend to the graphs. And this would be a reasonable graph for 3A. And I did this table, I'll say inefficiently. I didn't use the table feature on my calculator. And if you don't have a calculator that can do tables, this is going to be a way that you can get your y column. For 3B, I'm going to be lazy when I do my table and use my table feature on my calculator. But when you do 3B, you can do your table manually if you don't have a calculator that can do tables nicely. So 3B, same style of problem. It wants me to make a table, sketch a graph, and write the domain in the range. And because this is a square root, the domain in range isn't going to be negative to positive infinity. For our class, all domains of square roots are going to, square root graphs are going to be square bracket, comma, round bracket with infinity at the end after the comma preceding the round parentheses. And similarly, the range is going to be square bracket, parentheses, infinity, round bracket. And I just need to get the numbers that lead the domain in the range. This isn't universal. I can make a square root graph that the domain is going to be in a different form, but we're in the very beginnings of learning how to graph with square roots, and ours are just, they're basic square roots, and basic square roots graphs are going to work. The domains and ranges will be like this. So I'm going to get my table going, and I'm going to use the same values in the x column because if I'm not given a starting table, I take the radicand, I set it equal to 0, I isolate the x, and that's the number for the middle of my x column in my table. So my x column is going to have a -2 in the middle. Bigger than -2 is -1 and 0. Smaller than -2 is -3 and -4. And you can get the y's just like I did for 3A. Or if you watch the video that I showed how to do the table using this calculator and you own this calculator, then we can do the table on this calculator. So let me just get the y's in a lazy fashion. You can get the y's like I did for 3a if you don't have this calculator. But for this calculator, I'm going to get the table quickly by typing the mode button, hitting option 7 for table. Now I'm going to type in square root alpha in right parentheses for x plus 2, so there's the function. Hit equals. My table starts at -4. Type in -4 and hit equals using the negative by the fraction. My table ends at 0. Type in 0, then hit equals. And the numbers in my x column are 1 apart, so I'm going to do step 1 and equals. Now it's going to give me a table. This first column just numbers a point. It says the first point is the point -4 error. So the y next to the -4 is going to be 0. Then it says the second point is -3, comma, error, because if I plug the number in for x, I'd be left with a negative under the square root, and that's not a real number. The third point is -2, 0. The fourth point is -1, 1. And the fifth point is 1, 1.41. So way quicker to get the table that way than it is to do it once value at a time. So my y's only need to, I don't need negative y's, and my y's really only need to go up to 2. The first two lines on my table won't correspond to the graph. The first point I'm going to wind up graphing is the point -2, 0. And I usually write the first point that I graph in a square root graph because I need the values of that point for the domain and the range. And then the point -1, 1 and 0, 1.41. And square root graphs kind of have this kind of vibe to it, kind of a half of a U on its side. They go forever to the right. So now I'm going to finish up the domain. The domain is going to start at the x coordinate of the starting point for this graph, which is -2. And the range is going to be the y coordinate of that point, which is 0. Again, this isn't universal for all square root graphs as we get into higher classes, but in intermediate algebra, all the graphs we're going to do, if it's a cube root, the domain and the ranges are negative to positive infinity. If it's a square root, the domains and ranges are some number, square bracketed, comma, infinity. Now some junk that we did earlier in the semester, and I need to be able to make negative exponents positive. And in problem 4a, the first problem gives me an x with a negative exponent, and in order to make the negative exponent positive, I need to apply the negative exponent rule that x to the negative n is 1 over x to the n power, which means if you have a letter with a negative exponent, you can make the exponent positive by creating a fraction that has a 1 in the numerator and that exponent made positive in the denominator. So for 4a, it wants me to rewrite the problem with positive exponents. I'm just exactly going to use that rule. For part B, I'm going to shortcut the rule. If I have a fraction that has a negative exponent, to make the negative exponent positive, if that negative exponent's in the denominator of the fraction, I'm going to shortcut and move the negative exponent term up to the numerator, make the exponent positive, and multiply whatever I bring up from the denominator by the numerator. So 3 over x to the -2 is going to be written as 3x squared. That's a shortcut that we did in section P1. I left the videos up for sections 4.1 and 4.2. If you don't remember anything about the negative exponents, you might watch the video that I have for section 4.2. It's an old video. I don't have those problems online anymore, but you can watch the video for section 4.2 and it will show you in more detail these negative exponents. Part C doesn't have a negative exponent. I'm going to clear the parentheses by multiplying the exponent by any number or letter that has an exponent, and I'm going to attach the exponent to any number or letter that has an exponent. If there's a parenthesis that doesn't have any addition or subtraction in it, you can clear an exponent outside the parentheses by exactly that, multiplying and attaching. The x in my answer is going to have an exponent of 6. The y in the denominator in my answer is going to be 4 cubed, which is 64. For part D, we're going to use the other rule that I had for negative exponents, and it basically says if I have a negative exponent outside a fraction, that I can make that negative exponent positive by taking the reciprocal of the fraction. In part D, I have a negative exponent outside a fraction. I'm going to start and make that negative exponent positive by flipping the fraction or taking the fraction's reciprocal and making the negative exponent positive. This turns part D into something like part C. Now I have a fraction with a parenthesis with an exponent outside of it that doesn't have any adding or subtracting inside. And to clear the parentheses, I'm going to attach the exponent to both the 3 and the 2. And then 5 squared is 25. 3 squared is 9. For part E, I'm going to use the rule from section P1 that says if you're multiplying and the bases are the same, you do the multiplication by adding the exponents and not changing the bases. Part E, I'm multiplying two terms. The bases are both 4, so I'm going to do the multiplication by not changing the base, and I'm going to add the exponents. Generally, I don't leave numbers written with exponents, so I'm going to get rid of that exponent. My calculator is in table mode. I'm going to go mode followed by the number 1 to get it out of table mode so I can do 4 to the 5th power. I should get 1024 for my answer to part C. For part D, I can use this same rule. I'm multiplying. The bases are the same, so I could multiply by adding the exponents. And if I added the exponents, because they have opposite signs, I'm really subtracting. So I'm using this rule first. Now I'm going to combine the two exponents. Negative 5 plus positive 2 is negative 3. And now I'm going to make the negative exponent positive by using the negative exponent rule. I'm going to create a fraction with a 1 in the numerator, and I'm going to make the negative exponent positive by putting the term in the denominator. For G, there's a couple ways to do it. I could use the rule for dividing that says if we're dividing and the bases are the same, we could subtract the exponents. Or I could do it like part B and make the negative exponent positive. I think that's almost easier. So I'm going to do G like B. They kind of look like each other. I have a fraction that has a negative exponent in the denominator. I'm going to move the negative exponent up to the numerator like I did in part B. And I'm going to multiply the term from the denominator by the term that was in the numerator. I don't need to write a fraction anymore because I stole the entire denominator. And now I'm going to use the rule that I used in part E. I'm multiplying and the bases are the same, so I'm going to add the exponents. For part H, I'm going to make my negative exponent positive. Let me pause the video right now and do a part 2 on this, specifically because I only have a few minutes left. I don't know I can do a good job, so I'm just going to pause the video right now and do a part 2.